Hello guys, welcome back to our chemistry class. This is a video about Bohr's atomic model, part B, and we will be discussing about continuous and line spectrum. For starters, let's take a look at differences between continuous and line spectrum. So, continuous spectrum contains radiation of all wavelengths. An example of continuous spectrum is rainbow, in which there are 7 colors with no blank areas. While line spectrum only contains discrete lines separated by blank areas. What is the meaning of discrete lines? Discrete lines means specific lines in which the lines is being separated by blank areas. So this is what we call as a blank area. So between this blank area, there is a line in which this line will correspond to a specific wavelength. For an example, the red line is specific to 656 nanometer, while the green line is specific to 486 nanometer, and so on and so on. Next, let's take a look at the source of continuous spectrum. The source of continuous spectrum is white light or sunlight. And how does the continuous spectrum can be observed? Okay, so as you can see there, the sunlight will passes through a slit and a prism, and then after that, the light will be dispersed onto a white screen where the rainbow color is being observed. Take note that the spectrum is composed of visible light of all frequencies and wavelength. Next, the source for line spectrum is usually from light emitted from a gas discharge tube. And take note, the spectrum is composed of a discrete line. Discrete line means specific line with a specific wavelength. The question is now, why does the line spectrum only compose of a specific line? To answer that question, let's take a look how the line spectrum of hydrogen is formed. So there is total 7 steps. Let's take a look one by one in detail. The first step is when the gas is filled into a discharge tube. Okay, so gambar rajah ini saya akan potong bahagian discharge tube saja untuk tunjukkan kepada kamu. So gas itu akan dimasukkan ke dalam discharge tube dan biasanya kita akan gunakan gas hidrogen. Okay. Kemudian electric spark is passed through gas in the tube. So di situ ada tanda high voltage. High voltage maksudnya elektrik lah. So bila kita lalukan elektrik, maksudnya akan ada energi di situ, dan energi itu akan masuk ke dalam discharge tube. What will happen next? The energy supply is absorbed by electrons of the atoms. Dalam case ini kita pakai gas hidrogen lah. So ini akan menyebabkan elektron itu, sebab dia absorb energi kan, elektron itu akan move from ground state to a higher energy level. Sebagai contohnya, kita ada elektron pada n equals to 1. When energy is being supplied, elektron itu akan absorb energi itu dan dia akan move to a higher energy level yang mana n itu equals to 4. Contoh yang satu lagi adalah apabila elektron pada n equals to 2 absorb energy elektron itu akan move to a higher energy level, yaitu n equals to 4 juga. Remember that when electron is at the excited state, which is higher energy level, it is very unstable. So what will happen? The electrons will drop back to a lower energy level and emit light. So electron yang move to n equals to 4 tadi at excited state is very unstable, so it will drop back to a lower energy level. Jadi bila dia drop back, dia akan emit light, yang mana light itu adalah dalam bentuk photon. So the light that produced will pass through a slit and a glass prism. Okay, and then the light with specific wavelength and frequency will disperse into a spectrum, and that spectrum is called as line spectrum. So let's recap on how the line spectrum is formed. So when the electrons fall back to lower energy levels, you must remember this, photons are emitted in the form of light. So for an example, we have electron that is being excited at n equals to 2. Because it is being unstable, it will drop back to a lower energy level, which is n equals to 1, and it will emit a photon in the form of light. This will be can be observed on the line spectrum as one line. Next, if we have electron that is being excited at n equals to 3, remember, electron at excited state is very unstable, so it will fall back to a lower energy level, which is n equals to 1 in this case. So when it drops back to a lower energy level, it will emit a photon in the form of light, and then this can be observed in the line spectrum. This is another example on how electron that is at excited states will be unstable, and then it will fall back to a lower energy level, and during the process the photon is being released in the form of light. This will give rise to the third line on the line spectrum, the one with the pink color. Now let's take a look at another two examples on how the line spectrum is being formed. Enjoy! So remember guys, electron at excited state is very unstable. So what will happen? Electron will fall back or drop back to a lower energy level, and then when it fall back, it will produce a photon. Okay, which is a photon is a packet of light that have a specific wavelength and can be observed on the spectrum. So apa yang dimaksudkan dengan specific wavelength? Sebagai contohnya, kita tengok line yang pertama pada line spectrum itu yang berwarna hijau. Line itu mempunyai wavelength 700 nanometer. Manakala line yang kedua sebagai contohnya akan mempunyai wavelength 601 nanometer. And a special reminder for you, every line on the line spectrum, okay, dia mewakili satu transition, yang mana satu transition itu adalah apabila one electron drops from a higher energy level to a lower energy level. So one line, one transition, electron drops from higher energy level to a lower energy level. So the issue now is how can you read your line spectrum. So actually line spectrum can be read from your left or from your right. Okay, it depends on where the largest blank area is located. So here we have two line spectrum A and also line spectrum B. So let's take a look at line spectrum A first. So what must you look into the line spectrum before you read it? Okay, you must find the largest blank area first. So as you can see there, the largest blank area is at your left. So this will be your first line and this will be your last line. Therefore, for line spectrum A, you can read it from your left to your right. Seterusnya untuk line spectrum B, so sama juga macam tadi, sebelum kita baca, kita kena tentukan kita baca dari kiri ke dari kanan. So kita kena cari largest blank area dulu. So kalau kamu nampak di sana, largest blank area dia berada di sebelah kanan. Okay, so maksudnya garis ini adalah the first line dan garis yang ini adalah the last line. So maksudnya untuk line spectrum B, kita akan baca dia daripada kanan ke kiri. So itu sahaja untuk video kali ini. So kita akan masuk part C pada video yang akan datang. Thank you for your time guys. I'll see you. Bye bye.